So continuing from yesterday's notes, example 2, find the volume, leave answers in exact form. I went over what exact form was yesterday. We're going to do that right now again. Exact form. So this is example 2. Notice I got an oblique cone. The cone is kind of crooked. It's not straight up a right cone, it's an oblique cone. Notice that. Put out for a towel, thank you. It's oblique. Okay, in other words, instead of it being straight up like a normal cone, we got it's tilted to the right. So we call it an oblique cone. Let's find the volume only, not the surface area. We did surface area already. Let's just find the volume, but notice I'm asking an exact form. I want the exact answer. Right, Ramirez? The exact answer, which means I'm not going to replace pi with 3.14. I'm going to leave my final answer with pi in it, the variable pi. In other words, I'm going to express it in terms of pi. Let me write down my volume formula for a cone. What is my volume formula for a cone? Formula for a cone. Do you have your reference sheet in front of you? No worries. Toscano, help them out. What's my volume formula for a cone? Thank you. Katay, rock and roll. Nice. That's for a sphere. We're on the right track.
1/3?
Yes. 1/3 what, Ramirez? Nice. Times. Nice. 1/3. Remember, 1/3 the area of a cylinder. It takes 3 cones to fill up a cylinder. I showed you that yesterday right here. Yeah. Remember that? 1 cone is 1/3. 2 cones is 2/3. 3 cones is 3/3. So a cone is 1/3 of the volume of a cylinder. In other words, here's your volume of a cylinder right there. Just multiply it by 1/3 and you got a volume of a cone. That's kind of like the short end of it. Let's do it. What does capital B mean, though? One more time? Close. It's involved, but what does it mean? Area of the base. And the base, look at the base is a circle, so that means I need the area of a circle. So I'm replacing pi, or B rather, watch this, with the area of a circle. Look at pi r squared. Times the height. I'm looking for perpendicularity for height. Look at this is 90 degrees for sure. This tells me it's 90 degrees. Look at straight up. So the 4 is the height. So let's rock and roll now. Let me start substituting. Erase this garbage here. There we go. Okay, I'm not going to write approximation. I'm going to write equal, because I'm going to give the exact answer. I'm not replacing pi with 3.14. Clemente, I got the phone. I got the floor. Phone's away. 1/3. Watch this now. Pi. What's my radius of the circle? Where's my radius of the circle? It's 2 squared. Right. So I'm just replacing r with 2. Height is 4. Notice how I did not replace pi with 3.14 because I want an exact answer. I don't want an approximation. We went over this yesterday. Let's keep going. There we go. So 1/3 pi 2 to the second power, I want to say is 4 if my coffee is kicked in, times another 4. Again, I'm not replacing pi, so the volume equals, here we go, watch this. The volume is 1/3 pi times 16, right? 4 times 4 is 16. So the volume is, here we go. I want to multiply the 1/3 and the 16, so I'm going to swap the 16 and the pi. I'm going to put the pi to the right. So 1/3 times 16 times pi. Look at that. I just swapped the pi. I rearranged it. What's 1/3 times 16, and what do I do now? Thank you. Put a 1 underneath that puppy. So my final answer is, watch this, 16/3 pi. Done. It's improper, but is it simplified? Can I simplify the fraction? Is there any number that goes into 3 and 16 that's the same? No. So 16/3 is simplified. So there's my volume. 16/3 pi. What kind of units here? What kind of inches? Squared? Good try. Cubic inches. Look at the way I express it. 16/3 pi cubic inches. Or, if you don't like improper fractions, let's make it into a mixed number. Let's make 16/3 into a mixed number. How to make 16/3 into a mixed number? How many times does 3 goes into 15 without going over? 5 times, How many left over? Right, so 3 times 5 is 15, so there's 1 left over the same denominator. Look at, so 5 1/3 pi cubic inches. Either answer is fine. Look at, you want to express it as a improper fraction, fine, or a mixed number, fine. They're the same thing. Notice how my final answer has pi in it. It's the exact answer. It's equal. Volume is that. Come on, Clemente. Volume is that. Let's do it. By the way, if I wanted the approximate, I'll just replace pi with 3.14 right now and then multiply by 5 1/3, and I'll get the approximate answer if I wanted it. Here too, I could just replace pi with 3.14 at this point and then multiply the two numbers, and I'll get the approximate answer that we're used to. But if I want exact, you don't replace pi with pi. Just leave it in your final answer. Cool. Questions? So now if I ever say exact answer or leave your answer in terms of pi, that means they want an exact answer. No approximations. Don't replace pi with 3.14. Here we go. That's example 2. Let's try example 3. I got a funky, what we call a composite shape. It's kind of like a mailbox. So it's a prism. Watch this. You like the mailbox, Ramirez? Don't lie. Just going to write number 3. Find the volume of the composite solid. The way I would draw it is first draw the prism. Look at the bottom prism. Connect and then draw the half cylinder on top. Kind of like this. Do that again. All right, and then we're going to go the half cylinder here on top. I'll give you about a minute to draw that. Don't make fun of my drawing. Stop it. All right. Write the directions, though. Find the volume of the composite solid. Again, write C video if you're a crappy drawer. We're going to give an approximate answer. That means we're going to replace pi with 3.14. Okay. Erase my crappy drawing. and let us proceed. Bless you. What's the first example? Example 2 we just did? You didn't do it? Giving up on me? So we got a lunch pail of sorts. Nice. You haven't seen this word yet. Composite. Composite means made up of two or more things. Like this globe in my hand, Razo. It's a composite solid. It's a composite thing because it's made up of plastic and there's iron right here. This is made up of metal. So it's composed of different things. The word composed and composite have the same sound. Composite, composed. So this shape, this lunch pail, is made up, watch this now. What kind of shape is the top? That's a solid. Circle is flat. That's a three-dimensional solid. What kind of solid is that? Not a circle. That's a cylinder. How much of a cylinder? So look, I'm going to put half cylinder here. We're going to find the volume of that puppy of half the cylinder. What kind of shape is that? Good. It's a cube, which is a type of prism. Very nice. So I'll put cube here. Or prism. It's a type of special. A cube is a special kind of prism where all the sides are at the edge of the same. Very nice. There's our game plan. I just wrote down our game plan without you even knowing it. I'm going to find the volume of this puppy, find the volume of that puppy, add them up. We're done. Mission accomplished. Because they want the volume of everything. How many cubic feet fill in the whole lunch pail? The whole thing. Notice I said cubic feet. Yesterday you were dealing with cubic centimeters, right? You guys made this puppy, those cubic centimeters. But imagine cubic feet, big cubes that are a foot long on each edge. Let's do it. I'll do the half cylinder first. Here we go. Stay with me. In order to do the half cylinder, I need the cylinder formula, though. Can anybody give me the volume for the cylinder? What's the volume for a cylinder? I don't expect you to memorize them. It's on your reference sheet right in front of your face. Area of the base times height. That's a cylinder. Right, Razo? Let's see. Cylinder. I have mine right here. Here we go. Where's the cylinder? There it is. Area of the base times height. Sweet. Let's do it. But this is assuming the whole cylinder is here. Moreno just told us a little while ago we got half a cylinder. So what should I do with this formula? Nice. I can either put a 1/2 right here or just divide the whole shebang by 2. Look at it. Divided by 2. So I have half. Because I'm only dealing with half a cylinder. Right? So I'm going to put divided by 2. Think of the logic behind that. I'll find the area of the whole cylinder here, and I'm going to divide it by 2. That's going to give me the volume of that half cylinder on top of the lunch pail. So I'll put divide by 2. Now let's plug and chug. Let's plug in the stuff with what everything equals. Here we go. What is the area of the base here of the cylinder? So I'm looking at the cylinder now. I'm assuming the whole thing is here. Look at. Imagine the whole cylinder is here. The area of the base. What's the shape of the base of a cylinder? So here's a cylinder right here. That's the radius. Or that's actually just pi. I'm asking what's the shape of this? The bases are circles, right? The bases are circles. So a circle here and the circle on the other side. That's what the capital B means. It means the area of one of them, which means the area of the circle. So I'm going to, instead of writing capital B, let me replace capital B with pi r squared. That's the area of a circle. All I need is the area of one of them. This one. This one or the one in the back. Yeah, that's what pi r squared is all about. The height, how far away are the circles from each other? The front and back circle. How far away? 5 feet. Look at front circle, back circle in the back of the lunch pail. They're 5 feet. That's the height. So I'm gonna replace h with 5 now, divided by 2. So a lot of you are getting confused with this capital B. It means the area of the base. The area of the base is the area of a circle, so I wrote down the area of a circle formula. I noticed yesterday on the guided practice problem when I was walking around, you guys like stop right there. You don't know what's going on. Capital B means the area of a base. A base of a cylinder is one of the circles. It's in my hand. The top circle or the bottom circle are the bases. This means the area of just one of them, the top or bottom. That's the area of a circle, pi r squared. That was 2 weeks ago. Let's do it. I'll replace pi. So I want approximate answers, right? So I'm going to replace pi with 3.14. 3.14. Radius is, what would be the radius of that circle? One more time, Mathilda. Look, here's a circle. Here's the diameter is 5. Half of the 5 is your radius. So half of 5 is 2.5. 5 divided by 2 is 2.5. So my radius is going to be 2.5. Very nice, Mathilda. Here we go. 2.5 squared times 5 divided by 2. You with me, Rios? Come on, man. Work with me. Where's my calculator? There we go. Calculator time. Okay, here we go. So let's see, 2.5 to the second power. 2.5, oops, times 2.5 is 6.25 times 5 times 3.14. So notice what I did. I took 2.5 to the second power. It became 6.25. Divide all that by 2. All right, let me multiply all this stuff on the numerator now. 3.4 times 6.25 times 5. Here we go. 3.14 times 6.25 times 5. I get a whopping 98.125. I'm going to keep all the decimals till the end so my answer is more accurate. I'm going to divide all that garbage by 2 now. Divided by 2, because I only have half the cylinder, it's going to be 49 point, to the nearest hundredth, the second decimal, 06. Chickens, horses, or termites. We're dealing with volume. One more time. We're dealing with volume of this half cylinder. So what would the units be? What are we counting? Chickens? Close. One more time. That's covering, but we're filling it up. Cubic feet. Put feet cubed. There's half the cylinder. We got half the cylinder of the lunchbox, lunch pail, right there. Okay, so this is gone. Look, so we got the half cylinder. I'll put a check mark. Now I got to find the volume of the cube. Question so far? Volume of the cube is going to be, that's a prism formula. Okay, let me look at my prism formula. Let's see. The general prism formula is right here. Remember, we crossed this one out. You should have this crossed out on your reference sheet. The general prisms, volume is, look at the same thing, area of the base times the height. Same thing as the cylinder. So let me use that formula. There we go. So the cube, which is a prism, a very special kind of prism, is going to be area of the base times the height. So volume equals, I'm going to put it in blue now, area of the base times the height. Here we go. So I'm just focusing on the cube now. Look at the bottom base is a rectangle, it's actually a square, and then the top face is a square. Those are my bases, the top and bottom. Capital B means the area of one of them. So what is the area of a rectangle? This would be capital B, the area of the base. What is the area of a rectangle? The formula. Anybody? One more time. The formula though. What's the formula for the area of a rectangle? Length times width. So look what I'm gonna do. I'll replace B with length times width. And then the height is the distance between both bases. The bases are the two rectangles in blue, the top and bottom. They're opposite ends. They're always the bases, opposite ends. So the distance between the opposite end faces is 5. That's your height. So here we go. The length times width of the bottom face is 5 times 5. The height is 5. Just multiplying a bunch of 5s now. Nice. Nice. Chickens, horses, or termites, Toscano? Close. What kind of feet? Nice. There's our prism. There's our half cylinder. Let's add these puppies up. We're done. We got the volume of the half cylinder, volume of the prism. Let me get my calculator. 125 plus 49.06. Let's see. 125 plus 49.06. I get 174. There you go. So put V. I'm putting in black. The final answer is in black. 174.06. Chickens, horses, termites, or rats? Feet cubed. What do you guys think? No biggie, no biggie. One more time. You need a teddy bear? I got a teddy bear. Go ahead and you can hug the teddy bear you want tonight. Go ahead. The little boys, go ahead. Here we go. Any questions besides the complaining? Just kidding. Any questions? So that was example 3. Let's try example 4. Here we go. Let's draw a ball here. Let's draw a basketball here. Notice. Draw the middle circle first, and you got yourself a sphere, even though mine looks like an egg, but you get the idea. And notice the diameter is 6 meters. Go and try that one. The second to the last one. Here we go. Again, you got to be taking notes for your productive stamp. Find the surface area and volume. Exact answer this time. We're doing exact answers. Notice. Let's go, Rios. After this. Promise. Promise. I got more paper if you need some back here. Nice. Hey, it's pretty good. Good artist. You too. Hey, your spheres are looking good, you guys, I must say. Not as good as mine, but you know. All right, Rios, good. Good job, Razo. It looks better than mine. What's up with that? Give me the diameter, though. You write the diameter. You're going to need that for your reference. You want to write nice, detailed notes because you can use this on the first test and on the quizzes. The more notes, the better. Ready, Ramirez? Let's do this. This will go by a little quicker because I'm asking for the exact answer. We're not going to need to replace pi with 3.14. So let's go surface area first. We want both of the sphere. Here we go. Surface area. Yesterday we went over surface area in example 1. It's 4 pi r squared. Remember I opened up the baseball for you? The hard ball? It's four areas. Look at this, the area of a circle. That's 2 weeks ago. Just multiply by 4. Let's do it. Surface area then is equal. Look, I'm not changing to approximation. It's equal because I'm not replacing pi. So I got 4 pi. What's my radius? Close. 3. The radius is half the circle, right? From here to here. That's going to be 3. So I'm replacing r with 3 squared. Let's keep going. Look, this is going to be easier now because we're not replacing pi. Watch. 3 squared, I want to say, is 9 if my coffee kicked in. So I got 4 times pi times 9. What I can multiply the 4 and the 9. It's all multiplication anyway. So 4 times 9 is 36. 36 pi. We're done. Was that easier or what? That's the exact answer because I don't replace pi. So 36 pi what though? What are we? Chickens, rats? What are we counting? Close. What are we counting? Help! Thank you. What kind though? Nice, because the surface is squared. The covering. Think of covering as squares. You're like a square covering blanket. Just blankets with nothing but squares. All right. Surface area is done. I'll check off surface area. Let's do the volume now. Still an exact answer. Watch. Volume is that funky formula we talked about yesterday. It's 4/3 pi r to the what power? Remember from yesterday? Thank you. To the cubed. There's our formula. Are you with me? Come on. Are you with me? Nice. Watch this. We don't have to run away to mommy or hug teddy bears because we see fractions anymore because we know how to deal with fractions. Watch this. 4/3 pi. Radius in this case again is 3, but I'm cubing that puppy to the 3rd power this time. Whenever I ask for an exact answer, if you notice, it's kind of quicker. It's easier. I don't have to use as much calculator stuff. It's real clean and quick. Look at volume equals 4/3. Watch this now. Pi. 9 times 9 times 9 if my calculator kicks in right here. See, 3 times 3 times 3. 81, huh? Yeah. 3 times 9 times 3 is 27. Wait. 3 times 9 times 3 is 27. My bad. So it's 27 here. 27. 3 times 3 times 3. I want to multiply the 4/3 and the 27, so I'm gonna swap the 27 and the pi. Look at 4/3 times 27 times pi. I put the pi on the right. Pay close attention because there's going to be one more guided practice problem you're going to do on your own right now. So watch this move if you're really rusty on fractions still, which you shouldn't be, but shame on you if you are. Watch. 4/3 times 27, what do I do with the 27? Thank you. Multiplying by fractions. Look what I got now. Before I multiply numerator, denominator, I can cross cancel. I can simplify by cross canceling, like simplifying a fraction. Watch this, Villatoro. 3 goes into 3 1 time. 3 goes into 27 9 times. Nice. So look at the denominator is 1 times 1, and the numerator is 4 times 9, which is 36. So I got 36 pi. Bunnies, rats, chickens, horses, or termites? Close. What kind? Close. It's filling up space. Cubes. Cubic, is it feet or meters? I can't. That's cruel, man. You're cruel. You got me. Now I have to check because the knives are making me doubt it. It's meters, okay. That was cruel. I got you, though. Meters cubed. Done. It's easier. It's easier when you don't have to replace pi. It's actually cleaner. We're good to go. All right. All right. All right.